Okay, so let's get started with this example. And what I want to do is I want to show you how this example works and then use that to explain in general how to deal with an integral where the power of secant is 0 and it's the power of tangent is even. Okay, so the first thing I want to do, we're integrating the fourth power of tangent of x from 0 to the power of 4. The first thing I do is I'm going to figure out what is the integral of the fourth power of tangent of x dx. So first I do this, then I will evaluate it at the endpoints of 0 and power of 4. Now here's what we're going to do. We're going to pull off a tangent squared, a factor of tangent squared x with our dx, not with our dx, it's not really with our dx. It's just pulling off a factor of tangent squared. What we'll have left is tangent squared x dx. This tangent squared we can rewrite as secant squared x minus 1. Okay? So now when we distribute, we'll have the integral of secant squared x tangent squared x minus tangent squared x dx. Okay? We can split this up into the integral of secant squared x tan squared x dx minus the integral of tan squared x dx. So what we've done is essentially we started off with a tangent to the power of 4, and we're ending up with tangent to the power of 2 plus an integral that looks like something for power of secant is even. So this was one of the earlier cases we discussed. And in this case where the power of secant is even, what would we do? The power of secant is even. What we would do is we would pull off a secant squared. So we can figure out what is this integral of secant squared x tan squared x dx. Well, pull off a factor of secant squared x, and we're left with tan squared x. Now we can do a u substitution, because if we let u equal tangent of x, then du is secant squared x dx. Okay, so this integral ends up being the integral of u squared du, which is going to be u cubed over 3 plus a constant. But u, remember, is tangent of x, so we'll have tangent cubed x over 3 plus a constant. So this is equal to this integral of secant squared x tan squared x dx. So we're going to take this and put it here. Now, what about this integral of tan squared? Well, does everyone see how we've got this integral of tan squared left? So let's move to a different page here. And now for the integral of tan squared x dx, we are again in the same situation of power of secant is 0. And an even power of tangent. So essentially we have reduced this case here of power of secant is 0, even power of tangent. We've reduced it by 2 degrees. So this method is called a reduction method, because each time you apply this approach where you peel off a factor of tangent squared, each time you do that, what you're going to be left with is something that you can integrate over here, and something that's very similar to what you started off with, but a little easier to work with. So what are we going to do? We're going to peel off a factor of tangent squared. We're going to rewrite the, but here, do you see how there's really nothing to peel off? So we're just going to rewrite this as secant squared x minus 1, okay, dx. Now we can write this as the integral of secant squared x dx minus the integral of 1 dx. And now what is the integral of 1 dx? That's going to be easy. That's just going to be x. What about the integral of secant squared? That's just going to be tangent of x plus a constant. So, let's see here. So the integral of tan squared x dx is equal to tan x minus x plus c. Now we're going to take this and put it here. Okay, so we should have this tan cubed, copy, paste, okay, and then copy, paste, minus, this is equal to our integral of tangent to the fourth power of x dx. This is, we have our plus c. So the last step is, if we want to integrate from 0 to power over 4 of tangent to the fourth power of x dx, we just need to evaluate tangent cubed x over 3 minus tangent x minus, it's minus negative, so it should be plus x. All of this needs to be evaluated. X equals 0, x equals pi over 4. So this is going to give us tangent of pi over 4 cubed minus tangent of 0 cubed, all of this over 3, minus tangent of pi over 4 minus tangent of 0 plus pi over 4 minus 0. Right, so we're using our fundamental theorem of calculus, and we're just plugging in to each expression pi over 4 and 0 and subtracting them. Now, tangent of pi over 4 is going to be 1, so we'll have 1 cubed. Tangent of 0 is 0 minus 0 cubed over 3 minus 1 minus 0 plus pi over 4 minus 0. Okay, and we will end up with, can't remember, so I can't do this in my head, so let's just copy, paste, so this is the integral from 0 to pi over 4 of tangent of x to the fourth power dx. And so we'll get 1/3 minus 1 plus pi over 4. And that is our final answer. And we could actually simplify this a bit, I think. So it could be negative, so pi over 4 minus 2/3 as well. Okay, so just now let's go ahead and just do an overview. Okay, so what exactly have we been doing? So this is our overview. So you start off with an integral where, again, the power of secant is 0 and the power of tangent,
45.
Thank you, is even. So that means that your integral looks something like this, tangent to the 2k of x dx. So remember, 2k
It's 2145.
Right? This is the general formula for an even integer. So tangent of x to the 2k, right? This is what we start off with. We said we're going to peel off tangent squared x. That means we'll be left with tangent to the 2k minus 2 of x dx. When we peel off that tangent squared, we're rewriting it as secant squared x minus 1, tangent to the 2k minus 2x dx, integral. Next thing we do is we distribute. So I have the integral of secant squared x tangent to the 2k minus 2x, then minus tangent to the 2k minus 2x dx. And all of this we can write as two separate integrals now. Secant squared x, and then tangent to the 2k minus 2x dx, minus the integral of tangent to the 2k minus 2x dx. Now, this tangent to the, or secant squared x tangent to the 2k minus 2 is, what we can do is this, let's see here, this first one, we've already discussed how to work with it. Essentially what you're going to do is you're going to take that secant squared, couple it with the dx, we'll have secant squared x dx, and then this tangent to the 2k minus 1 is going to be tangent squared x to the k minus 1 integral, right? And we're ready for a u substitution. Let u equal tangent, right? Let u equal tangent. Then, let's see here. If we let u equal tangent, then du is secant squared. So we'll have u to the, I guess there's no benefit to writing it like this. We'll have u to the 2k minus 1. Right, so tangent x to the 2k minus 1. And that's ready for a u substitution. And then over here, this, we are back in our situation of having an even integer, right? Because if you have an even number and you subtract 2, you're going to be left with an even number. So you repeat this process again and again and again, and you continuously use your Pythagorean identity to until you get to a point where you're down to just tan squared, and the tan squared is just going to be, the integral of that is going to be tan x minus x. Okay?